In this video, I will show you how to perform the Kruskal-Wallis One-Way ANOVA in Spss statistics. Now you don't need to mind this formula over here. You'll only perform this when you're going to use pen and paper or solve it manually. As you can see, the Kruskal-Wallis H test is a non-parametric statistical test that uses ordinal data or ranks. And it is for multiple samples that are independent. We'll need to take note of that. So let's get started. Example 1. A group of students would like to observe the relationship between age and free time. They collected data from 4 groups: high school, college, working adult, and retired senior. These are the 4 groups. The table below records the number of free hours in a day that they have. These are the number of free hours that they have. Determine if the groups are the same. If not, which is the most free time? Similar to the one-way ANOVA, our null hypothesis would be all groups have equal amount of free time. Our alternate hypothesis would be at least a pair of the groups have more free time than others. Let's try this in SPSS. Age group. And we'll set the values to high school. So we've set the values for the groups. The measurement of this variable is nominal. So let's input the data. As you can see from the table, the sample sizes are unequal. We'll need to take note of that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 high school students. 1, 2, 3, 4, 5, 6, 7, 8, 9. They're 9 college students. They're everything else. And they're 11 students. Now let's input their records. So now let's test the data and go to Analyze, Non-Parametric Tests, Legacy Dialogues. Now if you can remember, the Kruskal-Wallis One-Way ANOVA deals with independent samples, not related samples. If it were related samples, that would be the Friedman ANOVA. Let's click the K independent samples. Our grouping variable would be age group, and the range should be from 1 to 4. Our free time would be the test variable list. Hit OK. Now if you would be computing the Kruskal-Wallis test manually using pen and paper, you might see something similar to this. We're using SPSS, so let's look at the test statistic. As you can see, the p-value is less than 0.0005, which is also less than alpha of 0.05. Therefore, our decision would be to reject the null hypothesis. Our conclusion would be the data provided sufficient evidence that at least a pair of groups have more free time than others. Since we've rejected the null hypothesis, how do we find out which has the most free time? Now, contrary to the one-way ANOVA, this non-parametric test has no post hoc test. So we'll have to do this subjectively. Let's go back to our output. This time, we will be looking at this table over here, specifically the mean ranks. Now if you're used to working with the Wilcoxon signed rank, the Fisher's exact test, the sign test, you will notice that you're using ranks for ordinal data, and you'll notice how to compute these ranks. Based on this table, when you look at the rank of retired senior, you can see that the mean rank is 34.72. Therefore, you can say that the retired senior is the group that has the most free time. So that's how to answer this question. If not, which has the most free time? It is the retired senior. Now, to test your inferential statistic, try to see if it is logically possible. As you can see from the descriptive statistical table here over here, that the numbers here is way greater than the three groups over here. And you can tell that they have way more free time than the other groups. So let's move on to the second example. And let's do this quickly. An academic competition was held to find out which school is best in the city. 7 students in 4 schools joined the contest, and the scores of the student representatives were recorded. We will be having 4 groups. These are the schools and 7 students each. Use the Kruskal-Wallis test to determine if there is no difference between the 4 schools. If there is a difference, which school is the best? Null hypothesis would be all schools have the same academic level, and our alternate would be at least a pair of schools is better than others. Or I mean, at least one of the schools. Same with this one. At least one of the groups. Now let's try this in SPSS. For schools, 7 each, 7 students per school. Now let's test this data. We go to Analyze, Non-Parametric Test, Legacy Dialogues, K Independent Samples. Now let's change the variables over here. School will be the grouping variable from 1 through 4. Our test variable will be scores. Hit OK. Make sure the test type is Kruskal-Wallis. We are given 2 tables. Let's take a look at this test statistic. Our p-value is equal to 0.855, which is greater than 0.05. Therefore, we accept the null hypothesis. Therefore, we accept the null hypothesis at alpha 0.05. Our conclusion would be the data did not provide sufficient evidence that at least one of the schools is better than others. So that's how you perform the Kruskal-Wallis One-Way ANOVA in SPSS statistics. That's it for this video. For more tutorials on statistical analysis using SPSS, save this playlist or subscribe to my YouTube channel. Thank you.